You're listening to CoachingCues podcast, where experts all around the world answer your most burning questions surrounding the wide topic of strength training. Every week we tackle the what, the why, and the how of one specific topic in just 15 minutes. Straight to the point, no fluff. So, without further ado, let's get straight into this week's episode.
This is Loenneke, and I've been given the question, do increases in muscle size contribute to strength gains? And this is a question that I've spent a great deal of time thinking about. So I'll just start by giving you my answer, and then reasons why I think that might be the case. So I do not currently believe that there's experimental evidence to suggest that a change in muscle size contributes to changes in muscle strength. I'll start off by acknowledging that it is true at baseline that people who are bigger do tend to be stronger. People who are smaller tend to be weaker. These are baseline relationships between muscle size and strength that have been observed for a long time. But it's important to realize that these same observations are observed in people who have never lifted weights in their life. So this baseline relationship doesn't necessarily inform us about what happens during exercise. In fact, it's important to really keep in mind what the question actually is. And the question is, when an individual undergoes a resistance training program and they increase muscle size, in other words, they see a change, does that change in muscle size contribute to a change in muscle strength? So we're talking about changes here, not baseline relationships. Now, the current model for explaining why individuals get stronger when they lift weights goes a little something like this. In the first couple weeks, an individual will get stronger, and this is predominantly thought to be due to neural adaptations. And then beyond that point, they have large contributions of muscle hypertrophy contributing to that strength gain. So that's the general story that's told in many papers. It's often assumed to be true in many papers. And it's the story that you will find in almost every textbook written beyond the 1980s. But I think it's worth considering what's the story based on? And a large portion of it seems to be based on really two early studies. And two early studies were really pivotal in changing how the story was told about the relationship between muscle growth and strength. The first one was a paper by Ikai and Fukunaga, and that was published in 1970. And then the one that's probably more popular and the one that's most commonly cited is a paper by Moritai and DeVries published in 1979. So just to discuss the first one, so the paper by Ikai and Fukunaga, they had 5 individuals train one arm. So they lifted weights on one side, and the arm that lifted weights got bigger and got stronger. The arm that did not lift weights got a little bit stronger but not bigger. And based on that evidence, they concluded that the reason why they got stronger was due to the increase in cross-sectional area and the increase in nerve discharge. So that was the conclusion, but I'm not sure that you can actually draw that conclusion from that study. The other study by Moritai and DeVries, they too trained 5 guys. 5 individuals came in, trained their right arm. Their right arm got a little stronger. Their left arm also got a little bit stronger, so the one that didn't train. But the thing that they saw in the arm that trained was a change in the slope of EMG. And because there was a change in the slope of EMG, they assumed that meant that muscle growth must have occurred. So it's important to realize that they did not actually measure muscle size in this study. They were inferring muscle growth off of a change in EMG, which I think has its own set of limitations. But the conclusion of this paper should sound very familiar. They too suggest that neural adaptations explain the first part of that strength gain, with hypertrophy becoming the dominant factor after the first 3 to 5 weeks. So these two studies really did a lot to set up the rest of the field on how they would tell the story about how individuals get stronger. So it's not to say that other studies have not been done since the 1970s, but that really did a lot for how people interpret the outcomes of their study. For example, if we look to the literature, it's worth thinking about the question of how is causality currently determined? In other words, how do we currently know in many studies whether or not muscle growth is playing a role with that change in strength? And I think what you'll find is this. If you look to the literature that looks at the response to exercise, if they see an increase in both muscle size and strength, they will almost automatically assume that muscle hypertrophy must have played a role. Whereas if they see an increase in strength, but no change in muscle size, then they'll say that, well, this was not due to muscle, this was due to neural adaptations. So if we think back to that first scenario where there's an increase in muscle size and strength, this alone is not enough to tell us whether or not hypertrophy played a role. Okay, just because we can detect a change doesn't mean it's a mechanism for another change. We have to ask the question about what would strength look like had muscle growth not occurred. And this is something that my lab has been interested in over the past probably 4 or 5 years. And we've tried to approach this research question using study design. In other words, we experimentally manipulate how much muscle growth each group has to determine what impact that has on the change in strength. For example, in the traditional group, where we'll create a situation where they see an increase in muscle size and they see an increase in muscle strength. And that's, what is traditionally observed. But in the same study, we'll create a group that doesn't see an increase in muscle size to see what impact does that have on the change in strength. And when we look at the other group that does not have muscle growth, we see the same change in muscle strength, which in our mind suggests that, one, that muscle growth is not necessary for a change in strength, which I think almost everyone agrees with. But I think it also suggests that muscle growth might also not be contributing to a change in muscle strength, given that the group that saw muscle growth saw the same change in strength as this group. And with the advent of very low load training, some of the things that we're also starting to see, as well as others, are changes in muscle size, but no change in muscle strength in the task of which they're training, which suggests that a change in muscle size may also not be sufficient for a change in muscle strength. Now, obviously, our model, we experiment to manipulate the growth. And some considerations of our model are as follows. So again, just to highlight that how we've chosen to try and address this question is not without its own set of limitations. We've primarily used B-mode ultrasound. Some people view this as a limitation. However, I think it's important to note that ultrasound does track pretty well with MRI. The duration of the studies, we've looked at this over around 6 to 8 weeks. We have no idea what this relationship looks like at 6 months or 1 year. But it is important to realize that this is a duration that's of similar length to the study of Mortine de Vries, which is a duration that was seemingly long enough to raise this question, but some people don't think it's long enough to question it. The training status, we early on looked at this mostly in untrained individuals. Again, the same population which was used to establish the narrative in the first place, but we've more recently looked at this in some trained populations and see very similar findings. There's also been some suggestion that the reason why we don't see an advantage is because we haven't given it enough time. In other words, the muscle growth is there, and we have an increased potential for strength, but we haven't been able to realize that strength potential yet. And that's a hypothesis, from the best that I can tell, which was originally proposed, or at least made popular by Professor Mike Stone. And I think it's a reasonable idea, but I think it's largely based off of cross-sectional data. And when we've tried to address this experimentally, we haven't been able to provide evidence that having an increase in muscle size can allow you to take advantage of that potential. But I think another criticism of our model, which I think is actually a pretty good one, is that when we experimentally manipulate growth, there are more things that are different between the groups than just how much muscle growth takes place. In other words, when we do these models, we have one group that's training close to a 1 RM, and we have another group that's training at around 8 to 12 RM. So the 8 to 12 RM is where we see changes in muscle size, and the group that's just doing the 1 RM sees a robust strength change, but really no change in muscle size. Now, I think in a simple movement such as the elbow flexion, I think that's less of a concern. I think it'd be a bigger concern if it was a barbell squat or a barbell bench press. However, it is an important criticism. And in fact, because of that criticism, it was suggested that a better way to do that is to look within each one of our groups and look at whether or not a change in muscle size mediates any of that relationship. So it was suggested that it might be better if we run some of these mediation models. And when we do that, what we find is that we do find a relationship between exercise and strength. In other words, those who lift weights get stronger. But when we determine whether or not that's explained by another variable, when we throw in muscle size there as a mediator, we find no mediation at all, which would suggest that changes in muscle size do occur in response to traditional exercise, but it does not appear to be explaining any of the change in strength relative to a non-exercise control. Now, it's obviously important to consider the random error across time. That's going to really impact our ability to see these relationships. But when we compare the random error of the ultrasound to that of the MRI, in many cases, it's pretty similar. So I don't think that this is an effect of just the ultrasound. I think we'd see a very similar finding if we were to look at MRI. So I think a follow-up question that I often get is, if muscle growth is not a mechanism for a change in strength, then what is? What might be explaining why individuals get stronger? And I'm not really sure, but I think that there are some good ideas that I think it's worth exploring. Obviously, neural adaptations seem to be in agreement by most people. In other words, we might have some sort of change in the brain, the spinal cord, or the alpha motor neuron itself. So it could be occurring anywhere along that path. But I think we should also consider potential changes at the fiber level that might be explaining some changes in strength that are independent of a change in muscle size. And in fact, some of these local level changes might be specific to the contraction history of the muscle. And I think that specific component is important, because one of the things that I think everybody agrees with is that strength is largely specific. So there's a huge specificity component. So I think anytime we start to try and explain why individuals are getting stronger, I think we need to look at mechanisms that can explain that specificity component. And obviously muscle growth can't do that. So I think that this offers an avenue of future research to really try and get at what might be explaining this specificity component. And I think that might help really inform us on what actually is contributing to changes in strength. So just to summarize the current evidence, in response to resistance exercise, I think that there are probably neural adaptations that occur. Obviously, muscle growth is also occurring in many cases, but I do not think that there's evidence to suggest that it's contributing to a change in strength at all. And I think although our studies that we've we've done to try and address this, although they're not without their own set of limitations, they are unable to find any advantage at all to increases in muscle size for changes in strength. And I think it's worth considering what the evidence proposed from the other side is. The evidence that they propose largely is driven by the fact that muscle size is correlated to strength at baseline, which again tells us nothing about the effect of exercise. The second point is that muscle size and strength measurably change, but that again doesn't tell us whether or not one contributes to the other. And the last is sometimes that they'll correlate a change in muscle size and strength, and sometimes, although quite often, they don't correlate, but sometimes they do. But again, when we look at a causal mediation, we find no relationship at all. So I'll just finish with the following. Muscle growth is not necessary for a change in muscle strength. It doesn't appear that muscle growth is even sufficient for a change in muscle strength. And there's no experimental evidence at all that suggests that a change in muscle size has a contributory effect on the change in muscle strength. Thank you.
Thank you for listening to CoachingCues podcast. If you would like your question to be answered by an expert, please head to coachingcues.org/ask. See you next week.